So in this module, we get into the exciting world of loops. So before now, you really didn't have a way to cause a certain block of code to just repeat over and over. You could, I guess you could paste the same line of code over and over. You could say print hello to the screen, and you can type that in once and then paste it 50 more times, 100 more times, and that's how you could cause something to repeat. But you really couldn't just designate a block of code to run over and over again. And this is really this is a critical part of computer science and programming in general, to be able to cause code to repeat. And so the book talks about two types of loops in Python, and you find these loops in every language, not just Python. One of them is a while loop, and the other one is called a for loop, F-O-R, not the number 4, but the letters F-O-R, the word F-O-R, for. So the while loop is what's called a condition-controlled loop. And you think, well, what does that even mean? So let me show you. So that old song about 99 bottles of beer on the wall or something like that, you can look that up in Google, but there's a song that goes something like that. And so if we say bottles of beer equals 99, and then we say while bottles of beer greater than 0, this is our first while loop, right? And it indents just like the if statement, and it has the colon, just like the if statement as well. This is what designates something as belonging to the while loop, if it's indented. So we'll say, we'll print the bottles of beer, and then we will type in on the wall, all right? And let's see, we need to cause bottles of beer to decrement each time this while loop is called. And don't worry, we're going to go back over this code here in just a minute. I need to get it typed in first. And now if we run this, what do you think is going to happen? This code, this while loop, will cause this code here to repeat over and over and over until bottles of beer equals 1. And then it's going to stop. So on the first loop, the first iteration of this loop, we know bottles of beer is 99. It's set right there. So is 99 greater than 0? Well, of course. So this loop executes, and it's going to print 99 on the wall. And maybe we should say, there we go, bottles of beer on the wall. And then bottles of beer, which is 99, equals 99 minus 1, which is 98. So now it's going to loop back through. And this time, is 98 greater than 0? And the answer is yes. So this prints again. And then the 98 becomes 97, right? 98 minus 1, 97. And then is 97 greater than 0? Yes. And if you're wondering, no, I'm not going to go through all 99 of these. But you can kind of get the idea here. So if we click run here, we'll run this. And you can see, we scroll back up through all of these, that indeed, it did print from 99 all the way down to 1. We can make it go to 0 by adding in the greater than or equal to sign here. And see, it goes all the way to 0 now. So this is a while loop. Now we can go a step further here. We can, let's see, let's come up with a different while loop. Let's actually go ahead and just comment this out for a moment. Let's try something maybe a little different, another type of while loop. Keep running equals yes. And then while, so we don't need the parentheses. Other languages require the parentheses, so I always want to add it. So while that's set to yes, we want to say it again. I don't know, just something. And then we'll ask the user, do you want to run this again? Okay. Now let's see where we stand here. It's set to yes, we'll keep running. This is a string. So while this string equals yes, it prints say it again. And then we ask the user, do you want to run again? And whatever they say, we set that equal to keep running. So this will print as many times as the user keeps entering yes or Y. So if we run this, it says say it again, run again. If we say yes, say it again, run again. And it'll keep going over and over as many times as we press this button, it'll keep doing it. What if I say no? Then it stops. Or what if I say just anything other than yes? It also stops, because we're not really looking for no here. We're looking for anything that's not a Y, right? If it doesn't exactly match Y, it won't run again. In fact, if we do uppercase Y here, it won't run again either. So that's pretty interesting. So up here, we were basing it off of a specific number, but a while is always called a conditional loop, though, because it evaluates this condition here or here. And it could be numeric based, where we are counting down, something like we were doing up here. But at the end of the day, the comparative result is still being generated here. It's still evaluating this and returning true or false, and then printing something. And down here, this could run literally an infinite number of times. We know going in, this is going to run 99 times, or whatever this variable is set to. Down here, we don't know how many times it's going to run. And that's what makes a while statement unique, is that it can run an infinite number of times, theoretically. Now, let's look at the other type of loop, and that's called a for loop, F-O-R. So we could say something like, for I in range of 10, and just maybe print out I. Now before we run this, look at this. It's similar to the while loop. The indented part of the code indicates this is a part of the for loop, just like up here. The indented part is what will run with while. Anything below this that's not indented will run, but it won't be a part of the while loop. And the same is true for the for loop. We added more code down here. It's not a part of the for loop. It's going to execute after the for loop, not a part of the for loop. But what do you think this is going to do? For I in range 10, we could change this to index in range 10. I is abbreviation, common abbreviation for index in programming. Maybe it makes more sense just to call it index. We could call it anything. But whenever we say range of 10, what are we talking about? Well, in Python, it's going to start, if we don't specify a starting point, it starts at 0 and it will go to 10, but not including 10. Okay, so it's going to start at 0, and then it becomes 1, 2, 3, and so forth. And it goes all the way to 10, but remember, 10 is not inclusive. So really it goes to 9, but it completes 9 and goes up to the 10th number. But it starts at 0, so it really is iterating 10 times. And so you could print someone's name if you wanted to. You could print Clint Eastwood 10 times without having to copy and paste this 10 times. This is one way of doing this. Now, something else to think about here with range. 0 is implied. When we have nothing over here, 0 is implied. So we could say it like this. We don't have to. This will run the exact same code that we just saw a moment ago. In fact, let's go back over here and just print out the index. See that? It's exactly the same. What if we do this? What if we start at 1? And now 0 is skipped and it starts at 1. So now it's really only going 9 times. because 1, 2, 3, all the way to 10, but not including 10. And you say, well, what if I want to include 10, inclusive? Well, then just pop it to 11, and now 10 will be included in this. So this gives you a lot of control, a lot of power over running the same code over and over and over. Now, interestingly, with this for loop, using range like we're doing, what if we want to skip every other number, right? So before, a moment ago, we didn't specify this at all. So it's assumed that you want to increment by 1. But what if we want to increment by 2? Index starts off with 1 because we say it starts off at 1. We're going to 11, up to 11, not including 11. And then we're skipping every other one. But just switching it back for a moment to this way, let me point out that on the first loop here, index is 0. I'm sorry, 1, because of the 1 here. It starts at 1. On the second loop, it's 2. On the third loop, it's 3. On the fourth loop, it's 4. Index increments, or in other words, increases by 1 every single time this loop runs. And so when we say 2 over here, we're causing it to increase by 2. And if you're wondering, yes, we could skip this even further, skipping 3. It's interesting that you can do this. Now, another thing that we can do that's quite interesting, let's take this bottles of beer thing again that we played around with up here in the while loop. Let's make something like this here. Let's say, let me change this back to 0. Let's say over here, we want to a 0. Let's just stop right there for a moment. And let's go ahead and I guess we can just print. Yeah, we can just print that. And let's close off that space there. You don't have to, but it just looks more right than what I'm used to seeing. Now let's run this. And what do you think this is going to print before we do this? It's probably not, it's not going to give us exactly what we had above. In fact, it doesn't seem to be giving us anything. So let's take a closer look at this. For bottles of beer, looks like I jumped ahead a little bit. Let's try this. Now, before we were counting backwards, and now we're counting forwards, right? It's starting with 0. This is the first iteration of the loop. Starts with 0, and then it goes to 1, and 2, and 3, and so forth. That's really not what we're looking for. What we're really looking for is we wanted to count backwards, didn't we? And one thing we can do, remember how a moment ago we specified how we skipped every other one up here by doing comma 2, right? And this is the start, this is the stop, and this is that third entry is the incrementer, right? How many is it incrementing by? Well, did you know we can do a negative number here? So now we're going to increment by -1. We're going to start at 99. We're going to go to 0 in increments of -1. So in other words, in plain English, we're counting backwards. That's a fancy way of saying, it's a programmatic way of saying we're counting backwards from 99. So let's run this real quick. And it goes all the way to 1 from 99. So this is another way of creating this loop up here, this while loop, using the bottles of beer theme. It's rather interesting. So we can comment this out, and we can, I want to point out one other thing too. Now, Python supports, as you know, a lot of languages do this now, called the enhanced for loop or the abbreviated for loop. It's where we want to say something like for name in Winkin Blinken, and nod. All right, and we're going to come back to the, oops, I did not need to put and in there. We're going to come back to this syntax here in just a minute, and I'll explain to you what exactly is going on here. Let's run this. We have 3 entries here, and let's run them. And it prints each one. So on the first run through this, name is Winkin, and that's why Winkin prints. On the second run, it's Blinken, and that's why Blinken prints next. And on the third run, name, right here, this name, is set to nod, and that's why nod prints. Now, what this construct is, you've probably never seen this. It is a list. Python supports lists of information. Just for ease of understanding, I define the list right in here. And we're going to cover list in detail in a later chapter, in a later module. But just so you know, we could say something like our name list equals, and we could do this right here. We could just take that out and we could put it up here. And then we could just reference the list name. And a list stores just a series of data. Like before, you would store this in a string. And these are strings, but they're separate strings. So rather than having to define name 1 equals Winkin, name 2 equals Blinken, and so on, because if you had, actually we would need to put these in quotation marks, wouldn't we? That's what it's complaining about, and it's right. We put these in quotation marks, then that may look a little better. But what if we had 100 items in our list? Do you want to sit here and type this 100 times? You know, name 2, name 3, name 4, name 5. It gets unwieldy. It's not manageable, and we have an answer for it. It's called a list in computer science, or an array. Python doesn't really support arrays, which is a different type of list. Lists are more flexible, and that's all we're going to cover in this course. But just understand that we can have a series of data. These could be integers, they could be doubles, they could be anything. It just so happens they are strings, and we're accessing them in this way. And again, if you'd rather me comment this out and go back to maybe the simpler syntax, or I think this other way, you've never seen a list before, at least at first, it's a little easier to understand what's happening all on one line. And you can see that a loop, a for loop especially, goes hand in hand with a list. Because if you have a list of data, which we're going to talk about later in later module, but when you have a list of data, the primary way to get the data out is to use a for loop, to iterate through the list. The first time it goes through the list, it gets the first item. The second time it goes through the list, it gets the second item. And the third time it goes through the list, it gets the third item, and so on. If there was 100 items, it would get all 100 in here. And again, the first time through the list, name is equal to Winkin. The second time, name is equal to Blinken. And the third time, name is equal to nod. And that's your introduction to loops. I recommend that you read the chapter because it's going to go into more detail. I just sort of hit the highlights here to get you started. But we have while loops, for loops, and then really a couple different types of for loops. We have our traditional loop where we are going through a series of numbers, what Python calls a range of numbers. And then we also have this abbreviated for loop where we don't really care about the numbers. We're just wanting to access data in a series, like a list,